Namaste children, welcome to Samveda e-learning program. Today we are continuing with the topic electricity, and this is the fourth session out of the 5 sessions of this topic. And in today's topic we are learning about the subunit resistors in series and parallel. Children, as you know already, in this lesson we have covered 3 subunits already: basic concepts in electricity, Ohm's law, and factors on which resistance of a conductor depends. Now today we are learning about resistors in series and parallel. Children, what are the learning points in this session? Resistors in series and parallel, equivalent resistance of a system of resistors, electric current and potential difference in a system of resistors, and solving numerical problems based on resistors in series and parallel. So, in today's class we shall see how to apply the Ohm's law along with the system of resistors in series and parallel. That means you are seeing also the extension of all what you have learned in the previous sessions. Before starting today's lesson, now I have one question to you, and to pose you that question, let us go into this activity. Children, now at homes we use many electrical appliances, and this is an activity to verify what sort of connection goes inside our homes. If I give you an example, at homes we use many electric lights, and if in a situation arises wherein one electric bulb, if it burns out, it will lead to the non-functioning of all the other electrical appliances at home, will you be using such an electric circuit? I am sure your answer is definitely no. That means what you want is, even if one electrical appliances is not functioning properly, you want the other appliances to be working perfectly all right at the same time. Come, let us see why this problem persists and why do we solve this in a different circuit. So here children, you are observing that we are placed 2 electric bulbs in the circuit and they are connected in series, that is one after the other. Now the switch is open. Now as soon as I close the switch, what will happen here? Yes, the charges will start flowing, and currently the ammeter you can see it is 0. So now I am closing the switch. Yes, we are seeing that the 2 electric bulbs are lit up, and you are observing the free flow of charges through those bulbs. Now if we come across a situation that one bulb gets burnt out, any one among 2, then what will happen to this electrical circuit that we built? Will the other bulb glow when one is burnt out? See, now in order to symbolize that one bulb is non functioning, I have disconnected one bulb. So as soon as I disconnect one bulb, now we need to observe that the switch is open. What will happen if I close this switch? Will the other bulb glow? What do you think, children? Yes, I think you have got the correct answer with you, but we need to verify it by completing this activity. So now let us close the switch and observe its impact on the other bulb, which is perfectly alright. Let's close the switch now. Yes, where is the current? No, even though the switch is closed, there is no electric current flowing through the circuit, hence there is no electric bulb is not glowing. So what is the reason? Yes, in this series circuit, if one electrical appliance is not functioning properly, then the other appliances will also not work properly. So do you want this type of circuit at homes, children? Yes, definitely no. because if in series connected electrical appliances, one appliance gets not functioning, then other also, the entire circuit doesn't function. Yes, you just saw this activity. So, what do you think about the electrical components or electrical appliances being connected in series and being connected in parallel? Yes, here we can say this is the arrangement of resistors or electrical components in series, one after the other. Which is the other way? Yes, it is the system which is where the resistors are connected in parallel, right? One below the other, branching of the circuit is happening here. Yes, children, here in this diagram you are seeing that the resistors are connected in series, right? Now, my question to you is whether when we connect the electrical components in series, the amount of current that flows through that each resistor, whether it will vary. So, my question to you is whether this resistor and when compared to these two resistors will be allowing the same amount of current will be recorded here in ammeter, or different amount of electric current will be recorded. Now, are you curious to know about this? Yes, come, let us go into this activity and see whether in this electrical components which are connected in series circuit, there the electrical current varies in each or whether it remains the same. That is our question. Children, this circuit we have connected 3 electric bulbs in series, and we have also observing that the resistances are 1 ohm, 2 ohm and 3 ohm. That means we have connected 3 resistors in series, and the potential difference that we have given is 12 volt, and the ammeter, the current that we are observing is 2 amperes. Yes, so children, what is the potential difference? V is 12 volt, current I is 2 ampere. That means you know the Ohm's law, V is equal to IR. So now I will disconnect this ammeter and place it here in between 1 ohm resistor and 2 ohm resistor, and we need to check what will be the electric current through the ammeter. Will it be same, children? Yes, I think you are thinking, right? So when the resistors are in series, this activity shows us whether the current varies at different points in the circuit. Now what we are observing? Yes, the current is again 2 ampere. That means earlier also it was 2 ampere. The current is not changing wherever we connect the ammeter in the circuit. So now again when we change it to another position in the circuit, the ammeter is showing the same current. So children, you need to remember that V is 12 volt is equal to 2 is current, 2 into what is the value of resistance then? Yes, it is 6 ohm. So how do we get 6 ohm here? By adding the 3 resistances, 1 plus 2 plus 3, it is 6 ohm. So 12 is equal to 2 into 6 ohm, that is V is equal to I into R by Ohm's law. So series resistances means we have to add all the resistances to get the total resistance in the circuit. That means 1 plus 2 plus 3 is equal to 6 ohm is the total equivalent resistance in the circuit that we can observe by the values in this activity. So children, you just saw this activity. So what do you conclude? In order to check whether we have learned through this activity, come, let us have an activity based quiz here. Now children, what will be the value of electrical current here when we are connecting the ammeter between 2 ohm and 3 ohm resistors? Yes, you are right. Come, let us see. Yes, again the value of electrical current is 2 ampere. Now in the same way, the next question to you is whether these resistors are connected in series. Yes, you already know. Now, if you want to measure the potential difference at the ends of the resistors, so what do you think the potential difference will be? Will it be same in all the resistances or different? Come, let us go into this activity and see how the potential difference will be. Children, this is an activity where we are seeing that resistances are connected in series, and now as in the previous activity we measured the electric current at the ends of the resistances, now we need to measure the potential difference at each resistance. Earlier we observed the current was not varying, it was 2 ampere. Now what will you think about the potential difference? So at the ends of 1 ohm resistor we are getting the value of potential difference as 2 volt. So V is equal to IR. Children, remember, so the voltage is 2 and the resistance is 1 ohm and the current is 2 ampere, as you can see in the ammeter. So 2 into resistance 1 ohm, we are getting 2 volt. Now what will happen at the ends of the 2 ohm resistor? What will be the potential difference? Yes, you are right, children, it is 4 volt. How? As you can see, ammeter is 2 ampere and the resistance is 2 ohm. So V is equal to IR, that means I is current 2 ampere and the resistance is 2 ohm, that is 2 into 2, the potential difference is equal to 4 volt. So this is how Ohm's law gives us the potential differences at the ends of a resistor. Now what do you think will be the value of the resistance or the value of the potential difference at the end of 3 ohm resistor? Are you thinking, children? As you can see, again between 1 ohm the potential difference is 2 volt because I into R, 2 into 1 ohm. Now the same way at 3 ohm resistor the potential difference will be, yes, the current is 2 ampere, the resistance is 3 ohm, therefore 2 into 3 by Ohm's law we are getting the potential difference is equal to 6 volt, as you can see in the voltmeter. So by multiplying the electric current, that is 2 ampere, and each resistance value, we are getting the potential difference at the ends of each resistor. So collectively, as you can, first we got 2 ohm, 2 volt, and next we got 4 volt across 2 ohm resistor, and then we got 6 volt across 3 ohm resistor. So totally 2, 4 and 6, the total potential difference is 12 volt. As you can see, at the ends of 3 resistors or 3 bulbs, we are getting the value of 12 volt. So resistors means bulbs here, because we have taken bulbs in the circuit, they have their own resistances, we can use the term resistors also. So children, total potential difference is equal to the sum of potential differences at each resistor, and the potential difference is not equal when the resistors are connected in series. In the earlier activity we observed the electric current is always same even though resistors are connected in series. So children, what you have learned there? Yes, you learned that the potential difference varies across resistors. Each resistor has its own potential difference, right? So the current value was same in each resistor in series circuit, but the potential difference varies depending on the value of the resistance. Now children, an activity based quiz for you. Come, let us go into this activity. So what will be the value of the potential difference across the resistance 1 ohm is the question to you. Yes, come, let us see what you have thought is right. Yes, as you can see, the potential difference is 2 volt. How do we get this potential difference as 2 volt? As you can see, it is by Ohm's law. V is equal to IR and V is equal to I, what is the value of I? It is 2 ampere I. And R1, what is the value of R1? It is the first resistance 1 ohm. So, we got the value 2 into 1, 2 volt, that is the potential difference of the first resistor. Now children, as you can see, we have written down the values of 3 potential differences that we got across the resistors. Now the total potential difference is 12 volt. Now what do you think? By adding 6 plus 4 and 2, what do we get? Yes, you are right. We are getting the total potential difference by adding the potential differences across each resistor. So now we can write the total potential difference V is equal to V1 plus V2 plus V3. V1 means the potential difference across the resistor 1, V2 means potential difference across the resistor 2, and V3 means potential difference across the resistor 3. Now by Ohm's law we know I into R, right? I into R. So this is the total potential difference, that is why we have taken total current I and total resistance Rs, that is the equivalent resistance. Rs means equivalent resistance when the resistances are connected in series. So here we have written down I into R1 for V1 by Ohm's law, again by Ohm's law I into R2, I into R1, R3. So by taking common we have got R1 plus R2 plus R3. Now we cancel I and I on both sides, they are same, because you saw that the electrical current was same everywhere, and equivalent resistance when the resistances are connected in series, Rs is equal to R1 plus R2 plus R3. So remember, whenever resistors are connected in series, then the equivalent resistance, if we want to find the total resistance in the circuit, we need to do what here? We need to add the resistances of each resistor. So here we will get in this activity, what is the total value of resistance? It is 6 ohm, 1 plus 2 plus 3, that is 6 ohm. Now we have learnt about resistors in series, how the electrical current is same and the potential differences across the resistors varies. Now my question to you is whether in this parallel circuit each resistor will allow the same amount of electrical current or the electrical current will be different. Let us learn this through this activity. Children, this is the activity where we have connected the resistors or electric bulbs in parallel connection, that is in a branched circuit, one below the other, and now we need to observe the electric current. What will be the value of the electric current? Will it be higher? As you can see, 1 ohm, 2 ohm, 3 ohm bulbs we used earlier also. Now we need to see whether the current will be higher. So yes, here you are observing, yes, the current is higher. That means when we connect the same resistors in series, we had got the value as only 2 ampere, but when the same resistors are connected in parallel connection, we are getting the electric current 22 amperes, which is around 22 amperes. So therefore we can say that whenever resistors are connected in parallel, we have lesser resistance. And second thing, when one bulb is worn out or burnt out, as you can see, the other 2 bulbs are functioning properly. And in series connection, we observed that if one bulb was not functioning, the entire circuit was collapsing without any flow of charges. And also in the series circuit, we observed that the ammeter was showing the same reading of 2 ampere. Now what will we do is we will measure the electric current in each resistor, that means in each branch of the circuit. So now in 1 ohm resistor, let us see what is the value of electric current in the ammeter, and you can observe that the potential difference is 12 volt that we have supplied. Yes, current is equal to V by R by Ohm's law. I is equal to V by R. V is 12 volt, R is 1 ohm in the first resistor. So 12 by 1 is 12 ampere. As you can see, the first resistor is 1 ohm and the total potential difference is 12 volt. So 12 by 1 is 12 ampere, that is I is equal to V by R. By making use of Ohm's law equation, we are getting the electric current in the 1 ohm resistor as 12 ampere. So children, what do you think that happen when we connect the ammeter near 2 ohm resistor? Will the electric current vary? Yes, let us observe it. In series connection, it did not vary at all. It was 2 ampere everywhere. Now we have connected it around 2 ohm resistor. Let us see what is the electric current flowing by switching on the switch. Yes, children, what are you observing? It is 6 amperes of electric current. So again, by Ohm's law, can you apply and calculate? Can you verify it? Yes. V by R. V is 12 volt, R is 2 ohm. So 12 by 2 is 6 amperes. So it's perfectly accurately we are getting the values by Ohm's law also. So children, what do you think will happen here to the electric current? As you are already observing, 12 ampere at 1 ohm resistor, 6 ampere at 2 ohm resistor. What will happen at 3 ohm resistor? You already know that it will vary. Yes, again by Ohm's law, that is potential difference is 12 volt and the resistance is 3 ohm, and total electric current in 3 ohm resistor is 12 by 3, it is 4 ohm. So we can conclude that in parallel resistors, the electric current varies at each resistor, and we can find the electric current's value by making use of Ohm's law. So children, this is the first thing that we have noted here. The other thing that we need to verify is the potential difference at the ends of each resistor. So how do we measure the potential difference? Yes, children, you are right. By using voltmeter, we will measure the potential difference across 1 ohm resistor, 2 ohm resistor, and as well as the 3 ohm resistor by making use of the voltmeter. So in series circuit, when you saw that the potential difference was varying, earlier we have seen that activity. Now what we need to observe is the potential difference at each resistor. Yes, children, as you can see, now we shall measure it across the 1 ohm resistor. By Ohm's law, what will you think? Yes, the potential difference is 12 volt. So how did we get 12 volt? The current was in 1 ohm resistor 12 ampere. So 12 into 1 is 12 volt. I into R. So in the 2 ohm resistor 6 amperes of current was there. So what will be the potential difference? Yes, children, you are right. It will be 6 into 2, that is 12 volt. 6 ampere of current was flowing, 2 ohm resistor. So the potential difference will be by Ohm's law, 6 into 2, that is 12 volt. By now you may be knowing the answer for potential difference at 3 ohm resistor. So again, as you can see, the value is 12 volt itself, because 4 ampere of electric current was flowing. So one good thing that we observed here is the potential difference is not varying at each resistor when they are connected in parallel. So children, what do you learn through this activity? Yes, you are right. You learned that when we connect the resistors in parallel, that means one below the other, then the electrical current that is flowing, it also changes in each resistor. It was unlike the case in the resistors in series, where the electrical current was same in all the resistors. Here it is different in each resistor, right? Here you can see it is 12 ampere. That means V is 12 volt and the resistance is 1 ohm. 12 by 1 is 12. So we are getting 12 amperes of electric current. You can see the potential difference is 12 volt and the resistance where we are measuring the electrical current is 1 ohm. So 12 by 1 is equal to 12 ampere is the electric current flowing through this 1 ohm resistor. So if you add these three values, it will be equal to 22 amperes. So now children, we will write it here that as in the series resistors cases, we wrote V is equal to V1 plus V2 plus V3. Here we will write electrical current, total electrical current is equal to the sum of electrical currents in each branch of the resistor. So, and here I we can write by Ohm's law as V by R, and Rp is the equivalent resistance when the resistors are in parallel. So, and here we have written the electrical current values for each resistor, V by R1 plus V by R2 plus V by R3. So, here we have taken the common factor V, and which comes across 1 by R1 plus 1 by R2 plus 1 by R3. By cancelling V and V on both sides, we get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The equivalent resistance of the resistors in parallel is equal to the sum of the reciprocals of the individual resistances in the circuit. So, we will get the calculating the value, we will get 11 by 6 ohm. Now children, my question to you is, connecting a bulb and a heater in series in a circuit is not advantageous or not useful. Can you tell me why? Yes children, here as you can see that whenever we connect the resistors or electric bulb and a heater in series, if one is faulty, then the other will not function, and also both of them need different amount of electric current. Therefore, if we put them in series circuit, then one will not function because the electric current needed will not be optimum for its functioning. So, children, let us recall what are the resistances, what are the variations that we saw, what are the differences that we see in resistors in series and parallel. Electric current in each resistor is same in series resistors, whereas in parallel resistors potential difference across each resistor is same, V is same here in parallel circuit, and in a system of resistors in series, the total potential difference V is equal to V1 plus V2 plus V3. But here the potential difference is same, but the current was changing. So, total current in the circuit with resistors in parallel, I is equal to I1 plus I2 plus I3. In the same way, the total equivalent resistance for the resistor in series is Rs is equal to R1 plus R2 plus R3. That means the total resistance is equal to the sum of individual resistances when they are in series. In the same way, in resistors in parallel, the total resistance is the reciprocal of the total resistance or the equivalent resistance of the system of resistors in parallel is equal to the sum of the reciprocals of individual resistances. And here when the circuit is in series, then the circuit breaks if any one component breaks or if any one component is non-functioning, but the circuit does not break even if any one component is broke or is not functioning. Children, in today's class we have learned what is the meaning of resistances in series and what are their values, and also what is the meaning of resistances in parallel, and how to find the values pertaining to that circuit where we see resistances in parallel. So, now whatever you have learned, you need to put it here in the form of homework, write it down. The first question, what are the advantages of connecting electrical appliances in parallel when compared with connecting them in series in a circuit? The second question, how to arrange the resistors 4 ohm, 8 ohm, 12 ohm and 24 ohm in a circuit to achieve highest resistances in first case, and the same thing you need to write for lowest resistances. How do we connect the 2 resistors or the 4 resistors? So, children, in today's class we have learned about the system of resistors in series and parallel, how the electric current is same in series circuit and how the potential difference is same in the parallel circuit, and also we have solved some numerical problems based on an activity. So, you try to learn more concepts out of this and try to solve more questions and keep studying.